Welcome to the deep dive. You know how we do it. We take your sources, sometimes pretty dense stuff, and pull out what you need to know. No jargon, just the core ideas and maybe some surprising facts. Today, we're really getting into the guts of the modern world, the internet. But we're looking at it through sources that describe it as, well, frankly, kind of chilling.
That's right. The material we're working with today doesn't see the internet's basic architecture as just, neutral pipes,
Yeah.
but talks about a vast, sinister network, even a digital prison. Sure, it enables all the global communication, your online banking, cat videos, but it also means critical services and, yeah, your boss, Slack, and you on vacation are all tied up together.
It's a really powerful framing, almost dystopian, isn't it? So our mission here is to unpack the actual stuff, the hardware, the rules, the software that makes this whole thing work, seen through this lens of what the source is called disturbing harmony.
Hmm.
What's important for you, listening, is to get how these fundamental pieces really underpin the sheer scale of, well, digital life and maybe control today.
Okay. To do that, we got to start with the physical layer, like the actual wires and boxes. Underneath all the code, there's a skeleton. So let's begin with nodes and links, the foundation.
Right, nodes and links. Let's break that down. When the sources talk about nodes, they call them the watchers. And these aren't just concepts. They're actual computers, servers, routers, the things processing every click you make, every message you send. The point they hammer home is the constant processing, almost like surveillance. And that line, they never sleep, ever. That's pretty stark.
Uh-huh. And if the nodes are watching, then the links are your digital chains.
Yeah.
These are the physical connections. Think fiber optic cables under the ocean, microwave towers, your Wi-Fi signal, all tying devices into this huge digital body. These links are like the veins, just pumping data constantly. Into the void, as they say.
Okay, that makes sense. So nodes process, links connect. Together, that's the backbone. It lets data flow endlessly. But if the backbone is the territory, what about the things controlling the flow? The border guards and local organizers. That gets us to the hardware maybe in your house or definitely at your ISP, what our sources call the unholy trinity of network devices.
Yeah, this Trinity, these three are crucial for actually moving the data packets around. They're the decision makers on the ground, so to speak.
Okay, first one, the router. They call it the gatekeeper. We mostly think of it as our Wi-Fi box, right? But its job is much bigger. It's the controller directing data between different networks. Like from your home network out to the wider internet or between big corporate networks. It holds the maps, the routing tables.
Exactly. And what's key is the router looks at the destination network, not necessarily the final device or the content. It's like a border agent for data packets. It decides, based on its rules, if your data gets to cross into the next network or if it, gets dropped, vanishes into the digital abyss is the dramatic phrase they use. It's making high-level directional choices.
Okay, high-level director. It's different from the next one, the switch. That's the Puppeteer. This one works much more locally, right? Connecting devices within one network, like all the computers on one office floor or everything connected to your home router.
And it gets called the Puppeteer because it's disturbingly efficient, as the source puts it. It doesn't just broadcast data everywhere within the local network. It learns the specific MC address, that unique hardware ID burned into your device for everything connected to it. So it builds a direct map. It knows exactly which physical port your computer is plugged into and sends the data only there. That's why they warn it knows where you are physically on that local network segment.
Wow, okay. That distinction is pretty neat. The router is about where between networks it's going. The switch is about exactly which device locally. Explains the creepy names. All right, third member of the Trinity.
Oh.
The modem. The Translator of Doom.
Yeah, this is the bridge. Your computer and home network speak digital. The connection from your ISP, whether it's cable, DSL, fiber, uses a different kind of signal, maybe analog, maybe optical. The modem does the translation. Converts your device's digital signals into something that can travel over the ISP's lines and vice versa. It's literally, as the source says, whispering your secrets to the vast network beyond. It connects your private digital world to the public internet.
And yeah, those blinking lights. Maybe they're watching us. Okay, but for any of this routing and switching to work, devices need addresses, not website names, but the number strings. Which brings us to the domain name system, DNS, or as the sources call it, the Internet's cursed phonebook.
Right. DNS does the dark translation. It takes a website name, you type in something humans remember, like www.example.com, and translates it into that string of numbers, the IP address, like 192.168.111 or whatever. Computers and routers need those numbers to find anything. They don't understand domain names directly.
And the sources really emphasize this. If we didn't have DNS, we'd all have to memorize those IP addresses for every single website. They call that medieval torture. And yeah, I can see why. It's this essential convenience layer we totally take for granted.
Totally. Now, here's the really startling part, and it connects to what we'll talk about later with centralization. The digital coven, they call it. Get this. The entire global domain name system ultimately relies on just 13 logical root server clusters. Now, they're mirrored geographically for resilience, copies all over the world, but there are only 13 authoritative root entities. 13 logical points of control for the whole internet's address book.
13. That seems incredibly small. For the entire world, that level of centralization feels really fragile. Like if something happened to those 13 simultaneously, the internet just stops being easy to navigate. Wow. Okay, so you've got addresses. But moving data between all these nodes and routers needs rules. Strict rules. The sources call them ancient rules of digital sorcery. Protocols.
Exactly. These are the agreed-upon languages and procedures for how data is packaged, addressed, sent, and received. Make sure it's orderly and, importantly, reliable.
Let's start with ones we kind of see. HTTP and HTTPS, that's how your browser asks for a web page, right? So many web pages for the darkness. HTTP just asks and gets. But HTTPS adds that S for secure. That's the encryption part, keeping things relatively private.
Relatively is the key word, yeah. HTTPS encrypts the data between your browser and the server. So someone snooping on the Wi-Fi can't easily read your password or, those embarrassing searches. But it doesn't hide that you connected to a certain server. That brings us to the foundation. IP, the Internet Protocol.
IP. This assigns the actual address. The source calls it a permanent digital tattoo, like a prisoner number for your laptop.
Yeah, every device connected needs an IP address to send or receive data.
But hold on, my IP address at home seems to change sometimes, especially if I reboot my router. How is it a permanent tattoo if it's dynamic?
Good question. That gets into the subtlety. While your public IP address might change, that's usually assigned dynamically by your ISP using something called DHCP. The source is talking about traceability. Your ISP always keeps logs. They know which customer account was assigned which IP address at exactly which time. Plus, often your home devices are behind NAT, network address translation, sharing one public IP. But the ISP and potentially the router logs know the internal IP of the specific device that made the request. So the tattoo isn't necessarily the number itself staying the same forever, but the fact that your connection originating from your physical line and account is always logged and traceable back. Hence, you can run, but you can't hide.
Okay, that makes the analogy much creepier and, yeah, technically sounder.
Yeah.
Right. Now, my favorite analogy from the sources, TCP, the Transmission Control Protocol. This is the obsessive one, isn't it?
Oh, absolutely. TCP is all about reliable data transfer. It assumes the network is unreliable, that packets might get lost or arrive out of order. So first, it does this formal setup, a three-way handshake, to establish a connection. Then it chops the data into numbered pieces, packets. It sends some, then waits for the receiver to send back acknowledgments, ACK, saying, yep, got packet number 1, 2, 3. If it doesn't get an ACK for a packet back within a certain time, it assumes it got lost and sends it again.
That sounds incredibly inefficient, like constantly checking and rechecking.
It adds overhead for sure.
Yeah.
But it's essential for things where you need every single bit to arrive correctly, like downloading a file or loading a web page. That's why the sources compare it to that paranoid friend who texts you okay 17 times. That constant checking is the mechanism ensuring your cat video or your email arrives complete, not just a garbled mess. It prioritizes reliability over raw speed.
Gotcha. Reliability through paranoia. Okay, so TCP/IP and HTTP get the data there reliably, but what about making it look like something on my screen? Now we're moving to the stuff that actually builds the web page itself, the dark arts of content creation.
Exactly. We're shifting from the network plumbing to the actual structure you interact with. Three main technologies here. First, HTML hypertext markup language. This is the absolute skeleton. It defines the content and the structure. Like, this is a heading, this is a paragraph, this is an image, but zero style.
Right, and the analogy was perfect, like showing up to a funeral in your pajamas. All the necessary bits are there, technically, but it looks awful and is basically unusable for most people.
Precisely. To fix that visual mess, you need CSS, cascading style sheets, the makeup artist. CSS tells the browser how the HTML elements should look. Colors, fonts, layout, spacing, everything that makes a web page visually appealing and organized. It transforms that raw HTML structure into something you can actually navigate and read. The sources had that darkly funny line, lipstick on a pig, but make it responsive so it looks good on phones too.
Oh, okay, and then the final piece, the one that makes pages do things, JavaScript, aka the chaos agent. We need JavaScript for all the interactive stuff, right? Menus, animations, submitting forms without reloading the whole page, making websites feel like apps.
We do. It's incredibly powerful.
Right.
But the sources point out the downsides. A lot of JavaScript runs on your computer, in your browser, client-side processing that can slow down your machine, drain your battery, and yes, JavaScript is behind basically 90% of the unholy pop-ups and notifications haunting your browsing experience. It enables amazing features, but it's also the source of a lot of web annoyances and potential security issues. Powerful, but definitely chaotic sometimes.
Okay, so we have the network, the addresses, the rules for moving data, and the code HTML, CSS, JS to build the page content. We still need something to put it all together for us, the users. That's the web browser, right? Your portal to digital purgatory, Chrome, Firefox, Safari.
Yeah.
The browser is the crucial piece of software on your end. Its job is to take all those codes, the HTML structure, the CSS styles, the JavaScript actions, these dark incantations, as the source calls them, and interpret them, render them into the visual web page that our feeble human eyes can understand and interact with. And that rendering, putting it all together, takes a lot of work, which explains that ancient internet proverb they quote. What was it?
Ah, yes. A browser is just a window into the abyss. The abyss has 47 open tabs and is using 8 GB of RAM.
Huh. Sounds about right. Each tab is its own little world. The browser has to constantly manage and render, eating up your computer's memory and processing power.
Exactly. But none of this works, browser or otherwise, if you're not actually connected to the internet.
Which brings us back to the ISPs, the internet service providers, the gatekeepers of your digital soul.
Yeah, your ISP is the company you pay to connect your home or business to the rest of the global network. The sources call it the global nightmare. They own and manage the crucial last-mile infrastructure, the cables running to your house, the local exchanges, the connections up to the bigger internet backbone. They maintain the infrastructure of doom.
And they are the ones who make that constant connection, that constant vigilance, a reality. The sources say ISPs are always watching. They maintain the connection, they keep the logs we talked about with IP addresses, and they basically ensure you're online 24/7, even when you really, really wish you could just disconnect for a bit. Their infrastructure makes sure there's almost nowhere to hide online.
And when you tie all these pieces together, the reliance on DNS, the traceability built into IP, the need for ISPs, the power of browsers interpreting complex code, you hit the final and maybe most critical point the sources raise: the decentralization delusion.
Right. The early dream of the internet was this totally distributed, resilient network. No central point of control or failure. A beautiful lie, as the sources put it.
Exactly. They argue that while theoretically the internet could be built that way, the way it's actually evolved, driven by business and practicality, it's created these massive choke points, centralized points of failure and control that can, as they say, kill access or freedom with the flip of a single switch. The original architecture's promise has kind of been undermined by how it's been implemented commercially.
And they give a really stark example, the AWS apocalypse, when Amazon Web Services has a major outage.
Yeah, remember those times. The sources highlight that because so many websites and online services rely on just a few giant cloud providers like AWS, Google Cloud, Azure, when one of them hiccups, half the internet vanished. That's the quote. Your banking apps, streaming services, work tools, even smart home devices suddenly offline.
Well, it shows just how concentrated things have become. It's not just the 13-root DNS servers being a potential bottleneck. It's also the cloud infrastructure.
Precisely. The centralization risk is layered. DNS is one layer. The cloud hosting is another. As the source perfectly puts it, one tech giant sneezes and suddenly you can't order pizza online. It highlights a real fragility built into the modern system.
So wrapping this up, what does it all mean for you listening? Well, according to these sources, the internet isn't just wires and code. It's this complex, interconnected system, a living, lurking nightmare, perhaps. Hardware, addresses, protocols, code, all working together in what they call that seamlessly sinister harmony, powering literally everything from your emails to potentially entire smart cities.
And hopefully by understanding these basic building blocks, the gatekeepers, the puppeteers, the dark translation, the chaos agents, the centralized choke points, you get a better appreciation for the sheer scale and maybe the unnerving nature of this digital world we live in. You can now kind of see the architecture humming away behind your screen.
Thank you for joining us on this deep dive into the digital prison's infrastructure.
And we'll leave you with the source material's final thought. Consider the implications of all this constant connection, this constant vigilance. Sweet dreams. The internet never sleeps, neither do the servers. Or your notifications.